So maybe you've worked with vectors in college or university, or you've done a little, light vector work now that it's become a little more popular. Uh, the short answer of it is, data is there's tons of unstructured data out there, and it can be difficult to search it because, oftentimes the schema is not well defined. And this data could be, text messages or any, random strings of text. It could be images, could be video, even music. This data lives all over the place. And one approach to dealing with that data and being able to search it is to create vectors with it. And a vector is just a series of bytes that represents the data. And in recent years, it's become, really within the past year or two, it's become really popular to store this data as vectors because as these LLMs and machine learning models have become more sophisticated, they are able to search vector embeddings very easily, and they can also, encapsulate complex patterns and recognize patterns and semantic meanings and intent in the data. So where you used to have a relatively difficult time searching through large volumes of unstructured data, now with the data as vectors, you can use machine learning models such as LLMs and things to search through the data very easily. So Redis supports embedding vectors. And a question that often comes up is, does Redis embed the vector or generate the vector embedding for you? And currently the answer is no. So the way that it typically works is you use an LLM like OpenAI or Gemini or Anthropic, one of the LLMs, and they come with a way to, or Hugging Face or something. They come with a way to generate embeddings. So you will pass your data to them, generate the embedding, and then store that embedding in Redis. And what Redis lets you do is index and search that embedding. So it can do semantic similarity search using vector embeddings. And we'll get into that later on in the demo. Now, as to why you might use Redis as a vector database, most people said in the poll that they use Redis as a cache. The reason you use Redis as a cache is to speed up your primary database. So your primary database slows down with large volumes of data over time. And typically what people will do is they'll store complex queries, the results of complex queries in Redis, so you can easily retrieve that information quickly. Well, currently, this may not be the case forever, but currently LLMs are, if you've worked with LLMs like OpenAI, ChatGPT, Gemini, you've noticed that it takes a while to get answers from these LLMs. So if I ask ChatGPT a question, it might take 5 to 10 seconds to produce an answer. A lot of times when you're, trying to create a real-time application, say like a chat interface with a customer, they don't want to wait 10 seconds for every answer to their question. So you can use Redis as a cache just to cache answers from the LLM. But what's really nice is you can actually use Redis as a vector store to cache semantically similar questions. And so if a customer asks a similar question to one that's already been asked, you can quickly retrieve it from Redis without having to go to the LLM and ask it the answer. So that's what we're going to talk about today. And we have a demo application, which we'll get you the code for this at the end of the webinar. But this demo application is a very simple application that we have essentially gone out to YouTube. We've summarized YouTube videos. We have the vector embeddings for the videos in Redis, and we created a little search engine on top of it. So what the search engine does is it allows you to ask a question, and then it will give you sample YouTube videos that answer that question or potentially answer that question. And it uses semantic search in Redis to figure that out. It actually uses retrieval augmented generation with that. So what that means is we're searching Redis, we're getting a list of potentially relevant videos. Then we're passing those videos to an LLM. So this app is coded to use either Google Gemini or OpenAI. We pass the videos to, say, OpenAI, and we ask that same question to OpenAI and say, hey, give us the answer to the question using these videos. And so it kind of narrows the scope of what OpenAI, what ChatGPT should answer. And so what you'll see here is when we ask a question, like Prasan can say, tell me about Redis streams. And what you get is, looks like we've already asked a question. So here we actually got an identical match, but what this did is we've already asked this question before. So we actually stored that question in Redis as a vector, and without even having to go out to the LLM, we found the answer here. So we've got, an introduction to what Redis, what streams are, the features, ordered, efficient, all the different things that you might use with Redis streams. And then at the bottom, we have our 3 relevant videos. So this can work for any question. This app is specifically coded with only Redis YouTube videos and coded to answer questions about Redis, but you could develop it for any other use case with respect to videos. The reason we created this app, or initially created this app, was if you've ever gone out to YouTube and searched for an answer to a question, you do get a list of videos, but oftentimes some of them make no sense. Like you might search for streams and you get a mix of, some Redis stuff, some Kafka stuff, and then maybe, an actual body of water stream, right? Or like a video about streams and lakes and estuaries and things like that. And so doing a search like this gives you a little bit more powerful way to search over a list of videos. So we have a little live coding demo for you today. And we want to show you, we want to break this app down into a series of steps on how you might accomplish, storing these videos and searching them, calling the LLM, doing the semantic caching with Redis, etc. So we can get into that.
Yeah.
So the first step with that is going to be transcripts.
Before going to that,
sure.
if you want to explain about this, like this is the new question, explain time series, and this is the first time response from the LLM.
Yeah, exactly. So in this case, we
now if we ask the question in different format, now it has come from the
exactly.
cache. The second one is much faster than the first one because we have skipped the entire
where the first one has to go out to the LLM, it might take 10 seconds. And then the second one gets cached in Redis. And even though it's a different question, it's not the exact same. So you might be familiar with when you're caching in Redis, maybe you stringify a query, use that as your key, and then the response is the value. And you have to know that exact value to get that exact key to look it up in Redis. But Redis has a powerful search engine, and we're taking advantage of that right now using vector search to actually get semantically similar searches. So in this case, you know that it's retrieved from the cache because our question here, without looking at the code or like observing it in Redis, our question here is tell me about Redis time series. But you can see the response was to a question, explain time series. Now, it's hard to perceive the amount of time when it's on somebody else's computer. You'll be able to run this. We'll give you the code at the end. But effectively, it takes, it can take 10 seconds to get a response from Gemini or from ChatGPT. And your response from Redis is very fast in comparison.
And also it's not free. Whenever you do an LLM call, right, a cost is associated with it. So you're skipping that entire cost.
So
And
Eric asked,
even for
how did you identify the original subset of videos only published by Redis? So this app lets you upload the videos. In the bottom right there, you see a little like upload button. You can just paste the video links or IDs or whatever in here. And what it does behind the scenes is it goes out and uses the transcripts of those videos and then asks the LLM to summarize those transcripts and provide example questions. And then it stores it in Redis. So we just pre-uploaded Redis specific YouTube videos in here.
Yeah, we'll go through it actually step by step. Yeah, this is just an UI demo.
Yeah.
Fine, right?
Someone asked, how do you mock the question asked to the question that is stored? Do you ask OpenAI or Gemini? So every question that we get, and we'll get into this a little later, but every question that we get, we actually generate a vector embedding and then use that to search Redis. So you'll see that in a minute. So the marker or timestamp on the web page, there's no real indicator, but what you'll get on the web page is you'll see the previously answered questions. So if we had asked the same question in like 9 different ways, and then we generated a unique response, you might see 9 different answers there. If it's a brand new answer, you won't see any of those previously answered questions. You'll just see the first response from OpenAI or Gemini. All right, let's continue.
Yeah. So we'll break down the concept into different pieces actually, and I will show you independent pieces and their output and their functionality. Okay, so before we start, actually, you have to do a small setup. These are the environment variables which you have to add in your env file. First one is the Redis URL. You can give your local connection string, and port, yeah, you can keep it same. Add an OpenAPI key and OpenAPI organization ID. So you can just go to your OpenAI account. Okay, you can generate the key, a developer key. I have generated my key. So, and you can do a credit recharge to it. And similarly, OpenAI organization ID. So you will just see it there. So personal, general, this is the organization ID. You have to use it. Then search API key. So search API key, we are using it to convert YouTube video to transcript. Okay. And if you don't want to do it, we already have a few built-in data which you can upload it directly. Next is Google API key. Even here you have to go to Google Cloud Console and create a developer API key. This we need it to get metadata of video like title, description, and those stuff. So that's it. So first step is to add these environment variables in your code. I have them. Yeah, then let's dive in. So I have around 6 scripts here. We will run each script through npm. Okay. Like if I do npm run 01, first script will get run, then npm run 2, npm run 3 kind of stuff. So let me explain the first code. So the first file is get video info. What are we doing it here? From environment variables, in environment variable, okay. So we have different properties, and I have given different YouTube IDs here. So from environment variables, it picks the video ID. Then we use an YouTube API. From that, we get video information like title, description, thumbnail, and that we add to Redis. Okay. So currently, I have Redis inside. It's a GUI tool to visualize Redis data. So currently, it's an empty database. Okay. So we don't have anything here. So let me run the script one. We'll go through the code. So npm run 1. So this particular file gets executed. So what it has done is from my environment variable, it has picked YouTube IDs. And for each YouTube ID, it has got title, description, and thumbnail. Okay. So one is like Redis and MongoDB cache aside video. Another was like JSON video and time series video and streams video. YouTube ID is nothing but normal ID. Yeah? Okay, so whenever you watch YouTube, right, every video has a normal ID. Yeah, like this if you go, right? Yeah, that video is fine. So whatever you see after V, right, that is the ID. Okay, so you click any video, you have an ID for it. So just use those IDs. You can pick any ID and add it in environment variable. Okay, so let's get into this script of this get video info. So initially I am just setting Redis connections. At end I am closing the Redis connection. So we are getting video information and adding it to Redis. So if you open the get video info, just create an instance of YouTube client. Okay, just give that Google API key from the environment variable. Then use YouTube API videos.list actually and give the videos ID. So you get the information whichever you need. So this part is little important. So snippet means you are telling that I need metadata like title, description, thumbnail. Content detail means like you need video duration and other properties. Okay, like video duration, upload date, video definition, so that kind of stuff. You can add different parts actually, and you will get the different details about the video. So once you get those details, we are looping it and adding it to a array. And that array, we are adding it to an Redis actually. So we are looping it, we are giving some prefix and video ID and adding that entire stuff to Redis. So that's how
So
we got this
something
data. Okay.
something interesting to mention here. So we're using, the video transcripts, right? So we have the transcript and the data, but the reason that we decided to use transcripts, so Gemini has and other
This
LLMs
is
have a
just
way.
video info actually. Like transcript will go to the next part. Yeah.
Yeah.
NPM
I'm
run
just
to.
we're about to get into the transcript. So what I'm saying is, so we create this video info so that later we can link out to the relevant YouTube video. So we'll have the thumbnail and the title and the ID. But the next piece that we're about to do is talk about the transcripts. So we chose to use the transcript of the video rather than encode the video itself. So now LLMs have a way where you can actually get vector embeddings for the actual video files. We chose not to do this because it's cheaper for us to call the LLM with text than it is to generate a lot of videos. So if you're generating, you have to consider your budget if you want to generate a bank of, hundreds or thousands of video embeddings, and transcripts are going to be a cheaper option there.
So yeah, through first script actually, we have generated we have got only video information, nothing much. Okay. Now we have the second script to get the transcript. So even that pulls video ID. Okay. It hits the search API, then it gets the transcript and we are adding into Redis. So if I go to this, so yeah, I have kept code similar actually of each file. So it's easy to understand. So yeah, initially you connect to Redis, then at end you close the Redis connection. Here you get the transcript and then you add to Redis. If you go to video transcript, so you import search API loader from LangChain search API. So give your API key. So once you have this instance and you give video ID to it, and you call loader.load, you get entire full transcript. Okay. So for the transcript, we are adding some more extra metadata. That's it. Then we get an array, and that array we are passing it to Redis. So in Redis, we are just looping it and we are saving it into Redis. So this takes a time actually because some videos can be long. So let it run. So yeah, it has converted one video. Like that, it will convert 4 videos. Second one. And this is not only the way, actually, there are many third-party APIs which gives you video transcript. Yeah, we have just chosen search API. So it gives around 100 free credits and you can drive over it. So this is the video transcript. So same video ID actually, we are using same video ID like this, all 4 video IDs in information and transcript. You click it. So by default, you get this entire transcript of that video. And at the end, actually, we are also adding some metadata to it, link and ID. Okay.
Yeah, so Google, many people when they're looking for transcripts, they Google has its own YouTube API that you can use. We found that the search API, the search API actually works better and is a lot easier to use, and it gives you 100 free
credits, yeah.
transcripts. So it was good to use for this demo.
Okay. So we have completed first and second script. First script, we have used YouTube API to get the metadata. In the second script, we have just used search API to get the transcript and add to Redis. Okay. So now, so once we have transcript actually, so the third part is to convert to, because transcript is very large actually, we want summary of that video. How do we do it is, so get a transcript from the Redis, pass it to token splitter. Okay, so that will break the large transcript into chunk files. Then we have to create a summarization chain in LangChain, or because typically LLMs or LLM prompts have a size limit. Okay, so you can't give a huge text as a prompt. So what we have to do is, so instead of one prompt, actually, you have to give two prompts here. One is the main prompt, another is a summary or refinement prompt. So first prompt works on the first split document. Then actually you give the remaining split documents in the chain actually, and it summarizes it. So we'll explain in the code, but yeah. So you split the transcript into smaller chunks, then you pass it to a LangChain actually, a set of prompts, and then you get a final transcript summary. Okay. So that summary you add it to Redis. So let me go through here. Same actually. Okay, you set up Redis connection. At end we close the Redis connection. We get the summary of video IDs, then we add to Redis. So if you go to transcript summary, so we have to initialize the LLM here, ChatGPT in our case, OpenAI. Okay, we pass an API key, and we have used a GPT-4 model in our environment variable. And yeah, organization ID. This is our summarization chain actually. I think people have used normal chains, like you ask a question, you get an answer in ChatGPT, right? You have not used any summarization chain. So it's available in LangChain. So you have to just mention as type as refine, and you have to give two prompts actually. One is question prompt, another is refine prompt. So let us go through both. Question prompt and refine prompt. Okay.
Yeah, so
So
what this does is if you it allows you to actually call the LLM multiple times if your video, so say you have like an incredibly long video that is outside of the context window for a single call to the LLM. This lets you call it multiple times, and you can actually chunk the transcript into smaller pieces and still get a summarization from the LLM as you go along.
yeah, so the first prompt is like, say, we are telling ChatGPT that, okay, the transcript of the video will be used as the basis for a question and answer bot. Provide some example question and answers that could be asked about the video. Make this question very specific. Total output will be a summary of the video and a list of example questions for the user could ask of the video. Let me show with some example actually. Typically, if it's a small question, right? You ask question, okay, you do like prompt, LLM gives you answer actually. But since we have a huge document, what we are doing is, instead of just Q1 actually, we are breaking it down to Q1, Q2, Q3, okay? So we are breaking the entire transcript into chunks actually. And then for prompting actually, we are adding this, we are broken down into chunks. Then for prompting, first we are taking the first chunk, then the initial prompt actually, okay, and we are asking that to LLM, and LLM gives us answer or whatever summary actually. Then we take this answer, enter LangChain does it internally actually, you don't have to do through coding, but you have to take this answer, then next you take the second chunk actually, Q2, okay, then you pass this prompt again, it will refine the answer. Okay, whatever summary we have, right? It refines it. Then again, you take this answer plus the next chunk, ask again same to LLM. It will give you refined summary kind of stuff. That's how it works internally. But yeah, through coding, if you would have done it through raw node Redis, you have to do this entire circus. But yeah, through LangChain actually, it's built-in kind of stuff. So you
Yeah,
pass two templates to it. One is like question prompt, another is refinement prompt. So if you see here, right, question prompt is we are telling that okay, I have given you a transcript, just give me the summary for it. But this is the first one. But if you see the refinement prompt, here we are telling that okay, you already have some summary. I am again giving you one more chunk to it. So just improve your summary kind of stuff. So given the new context, refine the summary and example questions. The transcript of the video will also be used as it's the same as above stuff. Okay. So this
and
understanding this concept. Mm,
LangChain actually lets you specify the size of the chunks you want to send. So it will um, you can kind of set it based on the context window of the LLM, and it will chunk it appropriately.
yeah. So by this style, actually, even for a large document, you can get a short summary, okay, by passing different chunks. So just straightforward, actually, instead of typically in LLMs, you give one prompt, but in refinement summary, you give two prompts, okay. So this is just an initialization. We are not doing anything here. So we have just created an OpenAI instance. We have created an video summarization chain. So from our DB, actually, for each video, we get the transcript. Then that big transcript, actually, we break it down into chunks. This is the first step. Transcript, we are breaking down into smaller chunks. So we use token text splitter. Even this is from LangChain, actually, text splitter. We tell it like chunk size, okay, like maximum, like 10,000 words actually here. So token is not only words, actually, it's based on your delimiter. It can be comma or space or whatever. Based on that, actually, it breaks down the text. So here we are telling that, okay, 10,000 tokens per chunk. Chunk overlap property means sometimes it's not right to break the entire text exactly based on the word count. Actually, you lose the meaning or context, right? So there can be small overlap, actually, like 250 words. You can have repeated content kind of stuff. So that's what it means. So chunk size and chunk overlap you give. So entire large text content is broken down into smaller chunks. Now that entire array of chunks you pass to that chain and just run it actually, okay, and you get the summary. This entire stuff LangChain internally does it, okay. So what I told you earlier, right? So that entire big text we have broken down into smaller text, and that first text it will prompt with the first one and it gets the answer. Then again that answer plus again it will prompt, you get the answer. Okay, then the third chunk, fourth chunk. So for every chunk, it keeps prompting kind of stuff till you get the final summary. Okay, so that entire repeated process is done by LangChain. So we can do through manually also, but yeah, LangChain provides you these utilities. So you get the final summary. So if you have any doubt, yeah, you can ask here because this is little important. And can run 3. It will take some time. Okay, so till now we have video info and video transcript. Now we are creating summary of that transcript. That's it. Actually, you get the summary. We are storing it in getting it in an array. Okay. Once we have that array, we are just storing it in Redis. Add to Redis
Prasant,
loop it.
can you go back to
Yes.
Redis Insight? I wanted to mention something really quick. So if you're unfamiliar with what we're using here, this is called Redis Insight. So Redis Insight is like a browser tool for looking at data in Redis. You're probably familiar with using a similar tool for other databases, like using dbeaver or MySQL Workbench or SQL
Mongo,
Server Management Studio, something like this. Uh,
MongoDB Compass. Yeah.
yeah, MongoDB Compass. This is exactly the same, or not exactly the same, but a similar product, but for Redis. And it can connect to any Redis database, whether it's on your computer, out in the cloud, in Redis Cloud, wherever. And you can do a lot of cool things with it. So you can search, you can use the CLI, you can use the profiler
Profiler. Have a profile.
to watch commands as they're run on your database. And then there's the workbench to visualize certain commands and things like that. And there's a lot more. So yeah, it's free to download and use on any Redis database.
Yeah. So here
How
we
do
are
we know
doing.
how many times LangChain called OpenAI internally to get the complete summary of the video? There is a way to figure this out. There's like some logging tools you can do with LangChain to figure that out. We don't have that
For
enabled
this
right
demo,
now.
yeah.
Yeah, but you can do that. Can you share the code repo? We definitely
Yes.
can. We will
At
share
the
this
end.
at the end, and we'll also send out an email later, and it'll have links.
It's generating usually. LLM calls are always costly and time taking.
Yeah, so now you're experiencing,
Yeah.
we only had 4 videos, right? But it's taken us a while to get the LLM response. So that's why, using Redis for semantic search later and semantic caching of the answers is really good.
Yeah, it's done actually. And now if you see, earlier we had info and transcript. Now for that each video, out of that large transcript actually, like which is like 8 KB, 10 KB, we got summary around 3 KB. Okay. So it just gives a rough overview of that video summary and normal typical questions people can ask on that particular video. Okay. So that's it, nothing much here. And a couple of meta ID. Fine. So this is clear, right? 1, 2, 3. Third one, yeah, we are just getting the transcript. Now, whenever you do a search, right, semantic search or whatever actually, so that LangChain or AI tools, they understand vectors, not means we don't do a string match kind of stuff. So our next task is to convert this particular summary generated into vector. Okay, so get summary from the Redis. We can use any embeddings actually, OpenAI, Gemini Pro, or Hugging Face model. Okay, even that has some sentence transformers where you can do semantic text search. Use any model actually, but whichever model you use here to convert it to vectors, right? While searching also, you have to use same model. Okay. So here we are using OpenAI embeddings, but yeah, in the demo app, we have both OpenAI and Gemini Switch. So get summary from the Redis, use OpenAI embeddings, then give it to Redis vector store. It has a method called add documents. So it will automatically convert your text into vectors and save it back to Redis. So let us go through the code. Fourth one. Same fashion, okay. Connect to Redis, attend, close the connection. So here we get initial raw text summaries from the Redis. Then I'll explain here, okay. So text summaries actually, yeah, video IDs loop it. This is the key. Redis.get that key, you get the summary, okay. So plain get Redis get. So once you get summaries actually, you get Redis vector store and pass this array of summaries to it. It adds, it converts actually as a vector and adds to Redis. So what is this get summary Redis vector store here? Okay. So first you have to define any embeddings actually. So here we are considering OpenAI embeddings. We have given its name, same GPT-4 model, give organization ID, vector store. So even this is an LangChain Redis integration. So you can use raw node Redis library. Even from that, actually, you can create vector embeddings. Or since you are using LangChain framework, even that has utilities. So you can just use that. So new Redis vector store, you define this OpenAI embeddings, give any index name actually. So with this index name, it will be stored in Redis. Just a second.
Yeah, and
Yeah.
the important thing to
Next.
note here, so we're creating the index in Redis, which we'll use to search later, and
And
we also are specifying the key prefix, but also the algorithm to use. So I'll paste this into chat. If you want to learn more about the algorithms available in Redis, you can read that article. But we're using the HNSW algorithm, which stands for hierarchical navigable small world, and it's just the type of graph that it uses to search your for vectors, store and search vectors. Then we're also using the I think it's called inner product distance metric. So when you ultimately calculate the vector similarity search, you're actually calculating a distance between the vectors, and that's what you specify here. And Prasan mentioned it earlier, but it's very important to use the same algorithm and the same embeddings for looking up vectors and searching vectors as it is for storing the vectors. So we're using an OpenAI embedding model here when we're summarizing videos to store in Redis, and we're going to use the exact same model when we're searching and when we're calling the LLM.
yeah. So okay, so index name, yeah, it's just a name. Key prefix, like each entry you are prefixing with some key. Algorithm actually, yeah, there are a couple of algorithms, popular algorithms. One is HNSW, another is flat. Okay, so HNSW typically people use when the content is very large, actually, like in our case, transcript. So some transcript can go in MBs kind of stuff. So when you have huge data and searching huge data, you need some graph model. Okay, and when you have small data, people use flat algorithm. Okay, so there you can do raw comparison. So that's much faster and more accurate. Here, actually, it's faster but less accurate because we are doing a graph comparison kind of stuff. And distance metric, you have again L2. L2 is nothing but a distance metric, point to point. And cosine is typically an angle metric. And IP is a combination of both and normalization. And if you want to know about this, right, more, we have also written a tutorial.
I sent a message out over Zoom that has a link to it. So
Yeah, this tutorial actually. So perform basic similarity search actually without using LangChain. Whenever you want to learn this vector related stuff, you can learn raw actually. So at that time, you will learn more about these algorithms and all. So here actually in this tutorial at last, you can see actually this tutorial is written by us only. Okay. So me and Will has written it. So all these tutorials related to vectors or in solutions, so almost all are written by both of us. So here you can see more about this particular
yeah, and that link is
LUCD, like
here.
L2 algorithm. Like this is like how it measures L2 internally, how Redis measures, how cosine similarity works actually. Cosine similarity takes people typically use for image comparisons. When you have two similar images and you want to do an image search actually, so you can just see an angle actually, like how both images look similar. But when it is in text kind of stuff, right? People prefer L2 or the IP kind of stuff. Then when you have to use HNSW or the other stuff, okay. So you can read this tutorial. So it has all that basics and explaining more about that algorithm stuff. So here you can see when to use flat and HNSW and other stuff. But yeah, we'll not go deep into algorithms. There are a few more. Yeah, so just two things are important here. Define your embeddings actually, okay? So you can use OpenAI. If you want to go with free open source, use Hugging Face, even that's better. Okay, no, you want a paid stuff, use OpenAI, Gemini Pro, whatever. So one is embeddings. The next one is the algorithm which you use actually. How accurate results you need, okay? And how you want that similarity search to be measured. So it depends on your data size actually. The speed, do you want to compromise with speed or the quality kind of stuff? So based on that, you define the algorithm and distance metric, okay? So that's it. So define this, you get an instance of vector store. Then you just add any array of strings to it. It converts to vectors and add to Redis. That's how easy LangChain has made. But if you see original stuff, right? Originally, doing raw actually takes more time actually. Okay, so you have to convert into tensors. That there are many methods to seed it actually, but yeah, through LangChain actually, yeah, you have to define it like this. Actually, you have to define types this. But yeah, through LangChain, it's just simple one method actually. Okay, you define. That's why people mostly use LangChain and Llama index. Okay, it has removed
Yeah,
that entire
really there's
complexity.
LangChain,
Yeah.
there's LangChain, and there's also Llama Index, and those reduce a lot of the complexity when working with embeddings and LLMs and everything. But we're not going to go too in depth into what's going on behind the scenes, but you can in some of our tutorials, and you'll see
Yeah.
it's pretty verbose.
So this is very easy actually. So you just define a normal instance and call this add documents, give some data to it. It has converted into vectors. So let us run this script actually. Thank you, Jennifer. In those tutorials, at the end, we will give some links. So you will get some basic idea actually. Okay, what is vector or simple algorithms and other stuff.
So one thing to note, generating the embeddings is a lot faster than calls to the summarization LLM, right? So summarization LLM can be slow, but the embeddings is usually a lot faster.
Now, see, earlier this was the summary, right? So yeah, just an English text. Now here is the vector actually. So we can store it in
So
binary
something
we are
interesting
using.
here, you can't really make sense of the actual vector, but what's stored alongside it is the content and the metadata. So what's nice, and you'll see this later, when we look up and do a vector search in Redis, you get the value back, and you actually get the content as well as the metadata you stored alongside the vector. And so you can use that in your response.
Yeah. So typically, like whenever in your application, right, whenever you search, so internally it is doing a vector search, but the answer, whatever you are getting back from Redis is, right, that is your data, this data content actually. And that particular content we pass to LLM, and then that summarizes the answer for you. But yeah, we'll go there. So this one is clear,
So
right?
somebody asked, is there a way to generate vectors more quickly instead of calling OpenAI or Gemini? There is. So you can use local. There are local models. Hugging Face has a lot of open source
sentence
models.
transformers you
Yeah,
can use it.
sentence transformers and things that you can use. What I'll say to that is, Gemini and OpenAI are obviously paid solutions. I found are typically better, but for your own personal use, like there's no problem using Hugging Face or other open source models that you can run locally, and they are a lot faster.
They are faster, but they are limited actually. They are trained on small set of data, and they are fixed
Yep.
actually. Not much development going on here. They are continuously updating their models internally, and they are testing on huge data. So the result on this and Hugging Face, you can see the difference.
Yeah. So I don't want to necessarily sell you on you have to use OpenAI or you have to use Gemini. It really depends on your use case, but
Yeah.
they're definitely on the cutting edge versus some of the open source models.
Fine. So we have seen this, right? 1, 2, 3, 4, all 4 scripts. They're getting till now. Here we have done like getting video information. We got then the transcript of the video. Then the transcript we have converted to summary. Then that summary we have converted to vectors. Now it's time to search it. Okay. So before we go here, okay, so whenever user asks a question, actually, so we convert it to semantic question, okay, through AI, LLM prompt. Semantic standalone question. What is semantic question means? User can ask like a very big question with sentiment that, okay, hi, I am this, tell me about Redis streams, a lot bigger question. So through OpenAI prompt, actually, we are converting it to simple format kind of stuff, like tell me more about or explain just streams kind of stuff. So this is more of simplified question. So user question, we are converting into a simplified question through LLM. Then that simplified question we are hitting on Redis actually. We are doing vector similarity search. So that question we are converting into vector, and that vector we are mapping with our Redis vectors. So like out of hundreds of videos, it can match with like 2 to 3 videos. So then it returns us 2 to 3 video documents. Okay. So video documents is nothing but this one, this vector plus this summary also along with it. So now that with that video document and the original user question, again, we give it to LLM. Okay. And that generates the human answer for us. So this one actually, okay. So whenever you do this search actually, like this question, so this question we are converting into simple question, and that simple question is being converted to vector, and then we are doing a vector search on Redis, okay. So that user question we are converting into simple question, then we are doing a vector search on Redis out of huge documents. Then whatever final small set of documents we get, that with original question, again we do LLM, then we get a human generated answer, which we show to user, okay. So let's get into the code. Fifth one. Initially, yeah, set Redis connection at end, close the connection. So here is the question: how to index and query JSON document in Redis? Okay, now how it works actually. First, we are converting into simple semantic question. Then we are doing some similarity search on Redis. Then we are doing here LLM actually. So we'll go one by one. Get semantic question. So all OpenAI APIs, right? You just give a prompt, it gives you answer. So here we are just giving one prompt actually. Like you are an expert in summarizing questions. Your goal is to reduce question into its simplest form while still remaining the semantic meaning. Okay, they can ask a very big question, but we are converting it to a smaller question with same meaning. Okay, so that's the motto of this particular prompt. Yeah, so the prompt and output we need it in a string actually. Okay, so that user prompt we are giving with an user question actually. Then we get a semantic question out of it. So once we get the semantic question, we do an VSS vector similarity search on Redis. So that user question we have converted into simple question. Then we are getting the same summary Redis vector store. Okay, how we have stored vectors, right? Same embedding, same algorithm, same distance metric. Okay, so you have to set up same Redis vector store. Then it's just one simple method actually. So we'll share one more tutorial actually through raw node Redis. You have to do a lot more stuff. You have to play with algorithms. You get some numbers. You play with that number. Here, just it's a simple question. Okay, like vector store. Just do similarity search a method. Pass the user question and give some number like how many results you need. KNN is nothing but k nearest neighbor actually. So if you do raw node Redis, there you have to specify algorithm and other stuff. Here it's straightforward actually. Just ask the question and tell how many results you need. So based on your question actually, if it matches to vectors in Redis, it gives you the result. Okay, so and returns you the result. So entire vector similarity search LangChain has converted down into just one single line. Okay, so you just define the store, then call this method, pass your question kind of stuff. Pass like
It's and Prasan mentioned this, but it's incredibly important. I mean, it's necessary for you to use the exact same embedding model, the exact same algorithm that you used initially, or else your results will be inaccurate, or that you might not get any results at all.
typically database queries, right? You have to write something like this on Redis to do the same KNN query. Okay, write the index name, do this query, sort by, give a blob, dialect, lot more stuff. But through LangChain, actually, in a human language, you are talking to a database. Okay, so you are defining a vector store and you are just asking an English question to it, and you are getting the result. So that's how it has integrated with all vector stores actually, not only Redis, Pinecone, and all other stuff. So entire integrations. So fine.
And I don't know if you mentioned this, Prasan, but the KNN stands for K nearest neighbors. All
Yeah.
that means is how many results do you want? So do you want, 3 results, 4 results, whatever? For our purposes,
It is
I
3.
think we're
Yeah.
trying to find 3.
So you just give a question and the return count you need it. So, okay, this one was like, we have converted user question to simplified question. Then we have hit Redis. Based on that, say we'll get 3 results. Say we have not got any results actually. Then what we are doing is, again, we are calling Redis with the original question once. So that we just want to try it out. Okay, with original question, can we get some result? Okay. Finally, once we get the result, right, then the original question plus the search result, we pass to LLM. So LLM is straightforward, right? You give some prompt and you expect a string output. Yeah, so prompt is straightforward. We are telling that you are expert in answering questions about Redis and Redis stack. Your goal is to take a question and some relevant information extracted from videos and return the answer to the question. And we are telling that in that output, how it should be actually, what format it should be, what content it should include. So a typical ChatGPT prompt actually, nothing much. Okay. So that ChatGPT prompt plus your question, once you pass and your videos, that entire data, okay, if you give some context, this is nothing but RAG actually, okay? So it's simplified RAG through LangChain. So the prompt with question and you give the video output. This one actually. So initially, user question has been converted to semantic question. Then you hit Redis, say you got only 3 documents. Then the original question you're passing to LangChain. That's what we are doing it here, okay? The original question, that video output 3 videos, then you get an answer kind of stuff from LLM, and that you are returning it to the front end. Let us just run it actually, npm run 5. So this takes time, LLM calls.
Yeah, so you can see there the similarity search in Redis was very quick.
Very fast. But LLM call is much slower. Means still here it was very fast actually, like converting into semantic question, hitting the Redis out of multiple video documents, enter large database. after once you get that smaller chunk, but the ChatGPT call is little costlier. So
Yeah, so that's why the final step in what we're doing here is we will actually store the answers as a vector, and so you can search the questions find similar answers to questions
in the next
instead
step,
of going out to the LLM. So it'll save you a lot of time.
So yeah, here we are not persisting anything here in the database. In the next script, we are persisting here. Just we are asking a question. This is how an LLM answer is. Okay, so we have asked like how to index and query JSON document in Redis. So it has went through that entire video summaries actually vector. It got the result. Then it has converted into human answer. So instead, you watching all those videos actually, you can just do and search. Yeah, it summarizes for you and just tells you the exact answer. Fine. But every time, like say you have uploaded a video and there are million people actually, so they can have the same question in different formats. And every time you hit LLM, so one is performance issue, another is like cost kind of stuff. So to prevent that, we use Redis here again. Redis is already a vector store, but yeah, even for semantic caching, you use it.
Yeah, so the basic concept of doing the semantic caching, it's done almost exactly like caching the initial summarized videos and looking them up, right? It's done exactly like that, except what we're caching instead is the question, right? And what we're storing beside that question is the answer. So we'll generate an embedding with the question, and then we'll retrieve the question out of Redis later, and we'll have the answer alongside it.
If you see our earlier image, right, we have done this entire process. Like we have asked a question, we got an answer. Say we call this as a flow file. So in flow 6, it's same actually. That entire file, once you get an answer, right, we add it to Redis. Okay. So in Redis, we will add both question and answer in Redis. So then next time, whenever an user asks a question, so first we do that question matching with Redis. Okay, like do we have KNN search on that user questions? Like do we have a similar question asked earlier to Redis? If yes, then we return all those question answers to the user. If no, then we go through the entire LLM process, this process file. Okay, then once we get new answer, again we add it to Redis. This is clear, right? Like same entire file process actually, but once you get an answer, you add to Redis. Okay. So next time, whenever user asks a similar question, first you search Redis actually, like, do we have it kind of stuff? If have, we return it. Else, we do the same search process. Let me show through code once. First running, then I will explain the code. Say I will ask again question, the first one actually, like last time, how to index and query JSON document in Redis. npm run 6. This is little time taking LLM call. So unlike earlier, actually, this time what we do is we save the answer in Redis actually. So currently, yeah.
Yeah, so you'll see there in the comment it said no cached answers found. So now we're going out to the LLM. We're repeating that kind of what we did before, where we go out to the LLM, get the answer, and return it. This time, we're going to store that answer in Redis. And so when we ask it again, we'll just get the cache.
Semantic caching and normal caching, that's the difference actually. Normal caching, you have to again search. If you search with same text, then you will get from cache. Semantic means it's a meaning kind of stuff. You search something similar, still you get the result. Okay, now this time.
So this is where it's really cool, because you might be familiar with Redis. You've used Redis as a cache, but like I said earlier, you have to know the exact key to get the value, right? Which works well when you have complex SQL queries or something like that, and you can turn them into some sort of key, and it's a determinate value. But in the case of these questions, you don't get the same question asked all the time, and you still want to be able to look up answers in the cache. So that's what we're doing here.
Yeah. So now this time, say we have cached the LLM answer. Okay. So here is the question, and here we have that entire answer. Now, actually, the next time, let's ask something similar question actually. Okay. Like explain about querying Redis JSON. Okay. It's similar to the first question, but not exactly the same. So this time actually it shouldn't hit the LLM. Okay, so it should just match Redis semantic caching. Yeah, see this time it's very fast actually, and
Yeah, so we got the same
you can see
answer
that cached answers
from a
found
different
one
question.
actually. Yeah,
Yep.
and if you
But it was
reload here,
instant. It was, instead of waiting 10 to 15 seconds for an answer, it was, under a second to retrieve the answer for us.
yeah. So that's it actually. And if you see, there is no entry in the Redis actually. Okay, so it has not generated one more LLM answer. It has just written the same answer. Okay, so that's it from my end actually.
Yeah,
Now
so that's it for us. We can answer
I
any
will
questions,
share.
but
I will share few links actually. So this
yeah,
is
we
the
can
current
share a
repo
couple of
link
links.
and the demo app which we have shown you, right? We have clearly explained that actually we have a tutorial written for it. Okay, so building an
Yeah,
this
so
entire
I'll share
tutorial you
this.
can follow that, and we have
So
an original demo app and that algorithm.
yeah, I shared the
Okay.
GitHub link to the YouTube app, and then here is the tutorial that goes alongside it. Okay. And Prasan shared it there too.
Yeah,
And we have
so
other vector searching tutorials on our website too, so you'll see those when you get out.
yeah, you
You'll also
start
get
with,
a link to this recording in an email after this is over.
and if you don't know, right, you start with basics actually. Okay, vector similarity search using pure node Redis kind of stuff. Then try to learn some small chatbot kind of stuff. Then semantic text search, semantic image search, or video queue. So you can see some more semantic related tutorials here. And every tutorial has a demo app also associated with it, which you can try. Okay. Now it's QA time. We are already past few minutes.
Yeah, I
And I'll
appreciate
stop
everyone
sharing.
for joining. If you have any questions, you can type them now either into chat or ideally into the QA, and we'll answer them. Otherwise, it's been fun, and
In
you will get a follow-up email with this information.